We are given this parallelepiped, which is topped with a pyramid. And our goal is to describe or represent some vectors in this geometric figure as a linear combination of the vectors A, B, and C. So we need to create vector chains out of these vectors. Now we can do this graphically, geometrically here. So let's look at the first vector that we want to describe, the vector AC. This is this vector here. And we can already see, so we need to go from here to here. So we can do this by first using the vector A. So we get here, and then adding the vector B to get here. So this first one will be, the vector AC is simply A plus B. That's the first one. So let's look at the second one. The vector BS, so that's this one up here. And we need to get from B to S, and we can see that we can use the vector C here. And we just have to double this vector. So we also know that F, so this is the midpoint of the line BS. That's why it's enough to double it. So BS will just be 2 times the vector C. All right, that's this one. So let's look at the vector SD. That would be this vector here. How do we get that? So we need to go down first here from S. We can do this by using twice the opposite vector of C. So 2 times or minus 2C. So then we will be here. Now to get from here to here, we can just use the opposite vector of A. So minus A. And then we need to go over here. Here we can just add B. This gives us then the vector SD. Now for the next one, vector HS, let's see where it is. That's the one here in the back. HS. So how do we get there? It looks like we could go this way, right? So this part here would be minus B, minus B. Then this part here would be A, so plus A. And then the last one is plus C. Oh, actually, I'm doing it wrong. It should be here, minus B, plus A, and then plus C, right? So that was HS. And for EC, so EC, just this vector here. How do we get there? So we could go down here, then over here, and then here to the back, right? So if we do this path here, then we will have the path, this is minus C, then plus A, and then plus B, right? So in summary, if you have an exercise that is of this type here, then it's always good to really draw that out, sketch it, and then figure out the path that gets from the starting point to the end point, and then just chaining the vectors accordingly. Also note that the solution is not unique. You could go a different way. So for instance, here, you could also go first here to the back, then over here, and then down here. So you would rearrange these vectors kind of. And that's the case also for the other examples. Now that's exercise A. For the exercise B, here, we need to give 2 points whose connecting vectors are determined by the vector A minus B minus C. So we need to find 2 points which have these connecting vectors. Let's do this. Let's do it in a way that, yeah, we need first a bit more space here. Let's move this down. And then let's first draw this vector here, A minus B minus C, to get an idea how this one looks. So we start with A. That's the vector A, right? Then we subtract B. So we'll have this vector here. So this is supposed to represent minus B. And then we also subtract C, so this vector here. This should look somehow like this. We subtract that. Okay. So the resulting vector will be this vector here. That's A minus B minus C. Okay. Now let's try to take this and see where this fits. So if we add it here to the point A, this doesn't lead anywhere. If we add it to the point E, this doesn't lead anywhere in the shape. If we add it to the vertex H here, then we see that we get to the vertex B. Now this wasn't 100% accurate, but if you do this accurately, then you will actually end up at the vertex B. So these are the 2 points that are connected by this vector A minus B minus C.